Welcome back. Problem 11-38. So statement is determine the variation in width B as a function of X for cantilever beam that supports a uniformly distributed load along its center line so that it has maximum bending stress throughout the length is constant. Uh, the beam has a constant depth T. So you can see this is the cantilever beam that is acted upon by a uniformly distributed load W at center line. There the thickness is or depth is T, and this total height width at this end is B naught, and at distance of x this width is equal to B. So you have to find this B as a function of x. You have to find B in term of x. Clear? And throughout the length maximum bending stress is constant. So let's start with the solution. So we know that maximum bending stress is equal to m divided by section modulus. So we do not have m. So what we will do is that we will cut the beam over here. Clear? And we will draw the free body diagram. So if I draw the free body diagram over here, so it will be like this one. This end will be straight. It will be like this. Okay, so here we have a uniformly distributed load, that is W. This is the total depth in T. Clear? And this distance is x, where we have cut this section. So whenever you cut it at the end, there will be a shear force V, and there will be a moment M. Let this is your point 1. So we'll find this moment by using equation sum of all moment about point 1 is equal to 0, taking the counterclockwise moment as positive. So about moment point 1 we have an external moment M which is counterclockwise, so it will be positive. The second moment is due to this distributed load. When we'll convert it into point load, so it will be W into X, and it will be acting at a distance of X by 2, and it is producing clockwise movement, so it will be negative. So I will write M minus W into X by 2 is equal to 0. I will also represent that this W, when converted into point load, it will be W into total length, which is X, and that this distance is X by 2. Now from here you will get this moment will be equal to Wx square over 2. So this is the moment. Now what about S? So we know that S is equal to I divided by C. So again you can see the section at X. This will be the section. So if I draw it like this, so this is the height T or depth T, and this total is B. You can see the half of this. If I clear it, you can see the half of this half is B by 2, and this half, so total is B, and this thickness H is T. So I for this cross section is equal to 1 over 12 B into T cube, and C will be equal to T divided by 2. So you can just put it over here, 1 over 12 B into T cube divided by T divided by 2. So it will give you T square into B divided by 6. Now you have section modulus and moment as well, so you can find maximum stress is M over S. So M is Wx over 2 divided by S is T square B over 6. Upon further simplification, you will get maximum stress is equal to 3Wx square over T square B. So this is your equation number 1, and that is bending stress at x at a distance of x. Now what if x is equal to L? So if x is become equal to L, so we are talking about this portion. So definitely you have this B, this width B will become equal to B naught. So B will be equal to B naught. So put it in equation 1. So when you put it in equation 1, sigma max at x is equal to L will become equal to 3WL square over T naught, T square over B naught. And this is your equation number 2. Now it is given that sigma max is constant throughout length. So what does it mean that at any length sigma is constant? So we will equate, this is equation 1 is at length is equal to x, and this equation 2 is length is equal to L. So equation 1 will become equal to equation 2 as per given sigma max is constant throughout length. So 3wx square over T square into B is equal to 3WL square over T square B naught. So 3 will cut with 3, W will cut with W, T square will cut with T. So we have been asked to find this B. So B will become equal to B naught x square over L square. So this is the answer, that B is a function of x. So B is equal to B naught into x square over L square. So if you have B naught, you have x, and you have total length. You can find this width B across any length. Clear? So I hope you have enjoyed video, and this was all about 11-38. I hope you have learned it. Those who are new to my channel, then subscribe it and press the bell icon so that you can get notification about my latest video. If you have any question, you can ask me in comment section. Thank you for watching.